Hey guys, how are you doing? Welcome back. In this video, we're building a very awesome project in Golang. So it's a Golang quiz application. It's quite simple. It's beginner friendly in the sense I'll be explaining every single line to you. So even though we'll be using concepts like Go routines and channels, which are slightly advanced concepts, but they're going to be used in a very simple way. And I'll explain every single line to you, so it won't be a big problem. So having said that, very basic knowledge of Golang is still required. If you have basic knowledge of Golang, that's amazing. We don't need to be an advanced Golang developer because I'll explain every single thing to you in this project. And before we get started, we'll take a small, quick demo of how the project works. I'll explain to you. And then we'll do a visual planning. So in many of our projects, we do the visual planning where we have a board and we go through how the entire project is going to be structured. And then is when we'll start writing the code. Okay, so that's the process that I kind of usually follow in as many projects as possible. So let's run the program and see. It basically asks you problems. So it's a mathematical problem. So the answer for this is 92. For this, the answer is 130. For this, the answer is 163, I think, but I'll make it wrong. I'll write 120 here instead because we want some wrong answers also. For this, the answer should be 135, but I'll write 150 again. And here it should be 87, so I'll write 87. Now it says your result is 3 out of 5. That is correct because two questions we answered wrong. And this is why result is 3 out of 5. Now, one way for our program to exit, as you can see, is once all the problems are done. That's one way to exit the code, the program. The other way to exit the program is we're setting a timer of 30 seconds. So those 30 seconds are over, then also the program will terminate. So I'll just show it to you quickly. Let me run the program again. And I'll just write here 92, but I'll keep waiting for a while. I'll wait for 30 seconds. Till then, I'll just explain to you that basically we will be using a struct, which will be the problem. So the problem will be a struct. It will have a question, this is the question and this is the answer. So the struct will have two entities, the problem, the question, and the answer. So this whole thing is a struct. Okay, so as you can see, 30 seconds are over and it says your result is 1 out of 5 because it didn't let me complete or didn't even ask me all the other questions because 30 seconds got over, right? So I can now enter to quit. So like I said, this is one struct, and all of these problems are a slice of structs. So we'll be using slices, we'll be using structs, and I've already told you we'll be using Go routines and channels. So it's an interesting project, all right? Now it's the time to take a look at our whimsical board. So I'll head over there, my whimsical board. Okay, here it is. So here we will make it full screen. All right, so here what I'm saying is that there is going to be a main file, and in the main file there's going to be a main function, and the main function is going to call a function called problem puller. So problem puller is a separate function. Now we'll start with a file called quiz.csv file. So all those questions that you saw will be read from a file. Now this project that we're building can also double up as how to read a CSV file in Golang. So it can double up as that, right? So essentially you're going to learn how to read a CSV file in Golang. So we'll be reading the CSV file and we'll be using the struct that I showed you, the problem struct. We'll be basically creating a slice of these multiple structs, and then we'll be basically parsing this file, right? That's essentially what we want to do. How we'll do it, let's find out. So we'll have a main function. Main function is going to call the problem puller function, which is basically which is responsible for pulling questions from the quiz.csv file. So the problem puller function opens up the quiz file, creates a new reader, okay, and reads the file. So these will be 3 separate specific particular steps that we'll go through, and we'll use external packages for this as well. So we'll open up the quiz file, which is the CSV file. We'll use something to create a new reader, and we'll use something to read the file. Now, whatever you read from the file, you want to send it to the problem parser function, which is another function that we'll have that uses the problem struct that we'll create to parse all these problems here in the quiz.csv file. So problem puller reads the quiz.csv file, problem parser then parses based on the struct. Now, CSV file, Golang cannot work directly with a CSV file. So you need to parse it into a struct. Struct is what Golang will understand. Struct or slice of structs. Slice is basically a collection of structs, right? Slice of structs is basically a collection of structs. It could be a collection of numbers or collection of strings. In this case, it will be a collection of structs. All right, so problem parser then uses, like I said, problem struct to parse it. And essentially, once it returns, so because problem puller had called problem parser function, so it'll return the values to problem puller. Problem puller essentially will return all the values to main.go, the main function. So it says here returns the problems from the file. So all of this has been processed now and parsed. So all of that will be returned to the main function. Now main function will loop through all the problems, print the questions. We've already seen that in the demo, prints all the questions, accepts answer one by one for every single question, and then verifies the answer, and then it prints out, calculates the result. So let me write that. Calculates the result, and it prints out the result as well. Now it's possible that going through this entire flow, some things are not very clear to you, right? And that's completely all right, because we have not yet started coding. And when we start coding and when we represent all of these steps in code, so code is basically telling the computer all these steps, which I've just told you. So you as a human being would understand this visually, but computers don't understand it visually. So that's why we write code. And all of these steps, what I want you to do is, I'll just zoom in a little bit. I think this is good enough. Take a screenshot if you want at this stage. This is step 1. Take a screenshot, and I'll just zoom down here. Take a screenshot here and keep this with yourself. Okay, or keep coming back to it at least. Open this in another tab and just pause the video here, and in another tab you can keep watching the rest of the video. So so that you will basically be able to refer to this diagram again and again, or take a screenshot now and then you'll be able to zoom in also, right? This is the whole diagram. Take a screenshot now, you'll be able to zoom in later on. And this is, in this way, you'll be able to look at the diagram and also look at the code, and both of them will match completely, because I'll be following these exact steps. All right. This is what I call as visual planning. I always do this before writing any code. Usually I try to do this as much as possible. And as a beginner developer, as somebody who's starting out, I highly recommend this, because this is what senior developers, they usually do this. Architects, definitely they do this, because this is something that helps them structureize everything before they even start coding. And this basically helps us to reduce the number of problems that might have occurred, right? Number of errors. So this was visual planning for you. Now we should start creating our own project. All right. So what I'll do is I will create a new project with you guys, and I will say here mkdir YouTube quiz, or I'll just say quiz go YT. Okay, quiz go YT. And now we'll open it up in code editor. Okay, here is where we'll create our main.go file. So I'll go ahead and create my main.go file. All right. Now here you want to create your quiz.csv file, which will have your quizzes or your questions. And CSV basically means comma separated values. So what they're going to look like is, let's say you want to have a problem, say 70 plus 22. And the answer is going to be 92. So comma separated. Now the whole beauty of this file is that it knows, it can differentiate between different rows, and also knows what's the value after the comma. So it knows that, you know, something that's after the comma could be the answer, this could be the question, and that's how we'll parse it later on. Okay. So the next question we'll write here. You can feel free to change these. I'm just keeping them same as my earlier program, right? The same questions I'm keeping, the one that I showed you in the demo. Here I'll keep 91 plus 72. You can keep different questions, like I said. So I'm creating 5 different questions here. Now when I'm showing you these, I'm just creating 5 questions. But like I said, you know, this is a CSV file. You can have as many entries as you want. Golang can handle a lot of data, and you can also download another CSV from somewhere else. If you have access to this kind of a CSV, you can download that from somewhere else and use it here as well, not a problem. So main thing being that the question and answer have to be there. All right, so coming to our main.go file, which is obviously the most important file because that's the only file in this project. So in our main.go file, we'll say package main. Okay, this is how you usually start your main files in Golang. So package main, and then you want to import some things. Importing basically means other packages. So Golang is very modular. Even things that Golang requires to print out stuff or accept values from the user are not part of the main Golang core Golang, right? So they're available as packages for Golang, and that's why Golang is very modular and very light, because it doesn't have to carry all the baggage of all of these different things like printing and scanning values and encoding, decoding, parsing flags, those kind of things. So we'll be importing quite a couple of things. Now, before you do that, I just wanted to let you know that I have installed a couple of Golang extensions in my VS Code. If you are a beginner developer, just know that you can use extensions, but you don't want to completely depend on them, because in an interview you might not have access to those, right? So senior developers, they usually get really good jobs because they're not heavily reliant on these extensions. But just to make things easier for you or make the experience better for you, you can go ahead and install these extensions if you want. So just go ahead and go to extensions, and the first 3 or 4 extensions that come up when you write Golang, just install them, because that's what I've done. And additionally, I just have tab 9. Tab 9 is an autocomplete. It helps me to autocomplete sometimes, so you can go ahead and install that also if you require. But otherwise, everything else is same. I'm just using VS Code. You could be using any other code editor, but VS Code is quite good for Golang. So let's get started with our main function. So I'll say func main. In our func main, we want to do a couple of things, right? So I'll start creating some comments. So the first thing you want to do is you want to get or input the name of the file, right? So you want to tell our program that, hey, there's a file called quiz.csv, and that's the file you want to check out. That's the file you want to process, right? And then you want to set the duration of the timer, right? Like 30 seconds. In my case, I had put 30 seconds. You can change it, obviously. Then what you want to do is you want to pull the file, right? Pull the problems from the file. Now for this part, pulling the problems from the file, we will be using our problem puller function. So in essence, we are just calling our problem puller function. Makes sense? The one that I showed you in the diagram, we'll be calling another function for pulling the problems from this file. And then whenever you have an operation like pulling things from a file and returning them, you might have an error. So we'll handle the error here. And we want to create a variable to count our correct answers. Okay. And then we want to create, using the duration of the timer, we want to initialize the timer. So we have set the duration of the timer, or we have basically taken a value that would be the duration of the timer, but using that we want to initialize the timer itself. Initialize. Okay. These are some of the things that we'll be doing in the main function. The most important thing that we'll do in the main function will come after this, where we will do the whole processing part. So we'll loop through the problems, and we'll print the questions, we'll accept the answers. Okay, so this is the right way to do things, right? You plan it visually, you have all the steps mapped out, then you write down all the steps here, so that whenever you write code, you know exactly what you're doing. And we'll accept the answers and we'll calculate and we'll print out the result. Calculate and print out the result. Now, as you know, at this stage, we're calling our problem puller function. So what does the problem puller function do? You can create the outline of this function. So when I create this kind of a skeleton, right, where there's nothing, you're not actually written any code there, just written comments, but the skeleton has been defined by us. So this is something that I do in a lot of projects. You might have seen me doing this. So this is I do this because you have the skeleton, in the sense you know which function is going to call which function, but you have the steps written down, what's going to happen in each function, so that you get complete clarity on what's going to happen in this entire program. So you have problem puller. Problem puller needs to know which file does it need to pull the problems from. So we'll accept a file name, which will be string, and it's simply going to return a slice of all the problems. So I'm going to say slice of problem, or it might return an error. And this is why we're handling the error here, because it might return an error. So we want to handle the error, but mostly what we want it to return is the slice of problems. So when I say problem here, problem is our own struct that we're defining. So going back to the diagram, like I said, CSV files, Golang cannot work with them directly. So you want to define your own struct. Your own struct is something that will help you. So our problem parser function will use the problem struct to parse this file basically into something that, into a format that Golang will understand. So Golang understands structs or slices, does not understand CSV directly. We'll use a package to convert the CSV into and parse that into a slice of structs. And the struct is something that we'll have to define. The struct called problem. So somewhere at the end, we'll have to write type problem, which is a struct. And here, the problem struct has two things. It has a question, it has an answer. How do I know that? Because I just created the CSV file myself. It has a question, it has an answer. Straightforward, right? Then I know that I need to have a problem parser function, which will be called from problem puller. So the problem parser function, I'll say func parse problem, and it basically returns the slice of problems that I want here, right? So the slice of problems gets returned to this, and this in turn returns a slice of problems again back to the main function. So the parse problem, what does it take? It takes in lines being something that we'll send from problem puller, lines being something which basically contains all these lines. When I say lines, I basically mean all these lines, okay? So what does the problem puller function do? Now let's define that. Let's think about what's going to do. It is going to read the problems, so it's going to obviously read all the problems from the quiz.csv file. How does it do it? It will need to open the file, right? We will create new reader, new instance of reader. It will need to read the file, and after reading the file, it needs to call the parse problem function, and that's about it. We'll just call the parse problem function from here, and parse problem is just going to go over the lines and parse them. Lines are basically this data that it gets. It's going to just parse it based on the problem struct with problem struct. So I'll write that as well. So this is our plan. This is what we're going to do. And what we can do is we can get started one by one. So head over to your main function. Now input the name of the file. So what's the name of the file? Let's say the name of the file is fname, file name. We'll use the flag package. So f and quiz.csv file, which is the name of our file. And this is the path of the file, of the CSV file. Okay. Now you want to set the duration for the timer. So it's a timer is equal to flag.int t, 30. This is the timer of the quiz. Okay. Makes sense? So when I press Control S, usually it gets the package that I've just used. All these extensions, that's what they do for me usually. I don't know why it's not done that, but I'll write here flag because I'm using the flag package. Now it's giving me squiggly lines here because I've used these, but I've declared these, but I've not used these yet, right? And that's common behavior. So you want to pull the problems from the file. But before that, you want to parse these two flags that you've set right now. So you'll say flag.parse. So now Golang has your file which it needs to work with and has the duration of the timer. So we can work with these values later on. Now you want to pull the problems from the file. So what do you want to do? You want to call the problem puller function, as I said here. How do you do that? You say problem puller and you pass a reference to your file, which is fname, file name. You get back your problems or you get back your error. So I've already anticipated that we'll get back an error. And I've mentioned here that it returns an error. Problem puller might return an error, right? So the error needs to be handled out here. So we'll say if error is not equal to nil, what do you want to do? You want to exit. And we'll use the FMT package. FMT package is something that helps you to print out stuff and accept values from the user, that kind of stuff. So we'll say printf. And we'll just say something went wrong, keep it simple. And we'll print out the thing that went wrong. So it's a %s, comma, the error. You want to print out the error exactly. Okay. Sounds good. So we'll create a variable to count our correct answers. Now, are you seeing the ease with which we are able to write the code? Because we've done our visual planning, we have written these comments, right? So we're just following these comments now, and we're just thinking of how to represent that comment in Golang code. So that makes it very easy for us. You don't have to complicate things anymore. You don't have to worry about stuff. If you write code like this, what you're doing is you're doing something that they do with like what Navy SEALs do. The best way to eat an elephant, they say, is to break it down into very small bits. So when you break down a big task into very small bits, and you just focused on that small bit, at that particular point of time, brain is able to handle problems efficiently, and you're able to get the tasks done. Okay. So we'll correct. We'll have a variable called correct answer, and that's equal to 0. This is the variable that we'll use to count up our number of correct answers. And we'll create a new timer. So we've defined our duration for the timer. Now we're going to create or instantialize the timer. Instantiate, I don't know, whatever it is, we want to do that to the timer. Okay. So we'll say t object. Okay, that's our timer. So we'll say time.new timer based on time.duration. And here is where you want to pass your timer, reference to your timer variable out here. Here, that's where you've passed it, okay? And you want to multiply that by seconds because we want it to be seconds. If you write here hours or minutes, whatever, depending on that, it'll taken hours or minutes. But in this case, we just want it to be seconds. Okay. Perfect. Now the next thing, loop through the problems. So to loop through the problems, I will not do that right now because that's slightly bigger. As in, I want to do that after I get back the answers from, after I get back all the problems from problem puller, and once those problems have been parsed. So I want to do that at that time when I have those in my hand. And what I want to do now is I want to define a channel. So like I said, we'll be using channels, we'll be using coroutines. Channel, in this channel, we're expecting the inputs or the values to be strings. The channel is called answers, and C, which is basically answers. Okay. Now this problem puller function, that's the one we want to work with, because once you get those problems, only then you'll be able to loop through the problems, because that's what you get from this function. Okay, so let's work on that. So first, let's open the file. Okay, the way to do that is to open the file, you'll say os.open file name, and we'll handle the error while opening the file. So we'll say if f object comma error equal to nil. Okay. OS being your OS package, very common package with Golang. So let me try and save it. Yeah, so it was able to get OS and time package for me, which is perfect, which is what I needed. So I've done my open the file part. So I'll just copy this comment and I will paste it here. Now I want to do we will create a new reader part. So I'll paste this comment here. How to create a new reader? We'll say that reader is called CSVR, because CSV reader, that's the variable CSVR. So this is the right way to declare your variables. They need to be contextual, in the sense you have a lot of context here. Anybody else reading your code will know, okay, CSVR means CSV reader. So we'll say CSV dot new reader f object, file object. You have opened the file. Now you want to read the file. So I'll cut this, paste it here. How do you read the file? You will say CSV reader dot read all, and you will say if C lines and error. So you want to handle the error here itself, and if error is nil, then you want to return parse problem okay. So to parse problem, we know that call the parse problem function. So I'll cut this, I'll paste it here. So all we did was that now that we have read the entire file, we have all the lines in this variable called C lines. C lines is what you want to pass to parse problem, and parse problem is actually expecting your CSV lines. Isn't that awesome? Okay. So after this, you'll have an else, because if there's no error, you want to call the parse problem function. But if there is an error, what do you want to do? You want to return nil. You don't want to return any value from there, and you want to print out the error. So you'll say error in reading data in CSV. And you'll print out the name of the file. So we'll say file name, and we'll print out the error. Both of these things have been printed out. Okay, so if the error is not nil, you want to print out the error. Now for this one, which is opening up the file, what if the file does not open? So you want to have an else here. to try and handle that as well. So you will return nil from here, and you want to say fmt.errorf error in opening the file, and you will print out the file name, print out the error again. Okay, awesome. Now this is the best, I mean, you can skip this, but this is the best practice, having else statements for where you're checking for errors. You want to have these kind of else statements to handle the errors in case something goes wrong. You could have done it without having these f checks with the error checks. You could have done it without that, but then if there's an error, you won't be able to find it very easily. So with Golang, this is like a best practice where wherever you do something, an operation like calling a different package to open files or work with files, or even working with databases, right? Whenever you update something or you read something from a database, or whenever you're connecting to a database, if anything goes wrong, you want to print out. You want to handle the error there itself, and you want to print it out. All right. So a lot of the loop has been closed because problem puller, this is the final form of the problem puller function. We won't be adding anything to the problem puller function. What we want to do now is we want to add something to the parse problem function, which is an important function because this is what's going to help us take all those lines, all this. So now it has all this rough data from the quiz.csv file. So why we're focusing so much on the CSV file, we could have just taken those questions directly, right? But we're focusing on the CSV file because this, like I said, this complete project can double up as how to read from a CSV file, how to work with CSV files in Golang, any of those, right? Because we're working with a CSV file. So you want to pass the problem, and just note that it returns a slice of problem. So problems, you know, problem is a struct. Structs are data types that you define on your own. In Golang, you can define your own data types, which are a collection of data types that are already given to you by Golang. So Golang already knows about string, and so you have a collection of two strings, Q and A. And now Golang understands, okay, so problem is a new data type that you've created. It has a question, which is a string, and an answer, which is a string again. So you want to parse the problem, right? Parse the problem, returns a slice of problems. We know that now. So how do you want to do it? So you will create a slice of problems of length lines. Lines you're already receiving, and you have the length of lines, and you want to create the slice, which will be a slice of problems of this much length. And let's go through them. So we'll say for I is equal to 0 and I is less than length of lines, and you'll say I plus plus and R of I is equal to problem. So what you're doing here is every single line you're going through every single line. So you want to start I from 0, and you want to stop where the length of the lines end, because in our case it's 5, right? 5 is the length of the line. So you want to end there, right? Starting from 0 and just before 6, which is 5, so total 5 basically. Sorry, 0, 1, 2, 3, 4. So that's 0, 1, 2, 0, 1, 2, 3, 4. That's 5. So we want to stop at 4 because we have the total length is 5, right? So it'll execute 5 times basically. And you want to create this R, which is a slice, right? And it'll have multiple problems. It's a slice of problems. So it'll have multiple problems. So each problem one by one, you're creating it like this. You're saying Q lines I and 0, comma A lines I and 1. So you have a question and you have an answer. Question resides in 0th part, and the answer resides in the first index. And you'll access like the 0, 1, 2, 3, 4, and this is 0 and this is 1. So this is why there are these two indexes or indices, two indices here. I hope everything makes sense. If you have any questions, put it in the comments below. I'm going very slow, explaining every single line to you. And if you have any questions, like I said, put it in the comments below. I'll try and answer that for you. Okay, so before we move any further, I'll just define quickly a function that will help us to exit this program. So to exit the program, I'll say fmt dot print the message because of which we are exiting this program, and then I'll say os.exit 1. So standard stuff, using the OS package to exit this program whenever we want to. Okay. Now, what you'll notice here is that this function is supposed to return a slice. And we have not said that. So when we say return R, that means this R that we have defined here as a slice. Using the make function, we defined a slice of a particular length. We're returning that from the parse problems function. And this is what we get back when we call our parse problem function. Whatever we get, we are returning from there. Does that make sense? We're returning whatever is coming back from our parse problem function after we have passed C lines to it. We're returning that directly from our problem puller function. So everything is a closed loop now. We've done our problem puller function, we have done our parse problem function, we're done with the problem struct. Now it all comes to looping through the problems, right? So we'll loop through the problems. For that, I will create a problem loop. And this is where we can loop through the problems. So we'll say for I, comma p, range problems, we'll range the problems. We have used like a named entity here. This will help us very easily to break through from this loop, or to call this loop easily later on, you'll see. So here we'll say var answer string. We'll define a variable called answer, which is of type string. And we have now started ranging through the problems. That's what we said, we'll loop through the problems. So we're ranging through the problems. So you can range through anything in Golang using range, or you can use for loop. It's all the same. And we will say fmt dot printf problem is %d %s. So I'm going to write the question and the answer, but answer is what the user will say, and the problem, this will be the question. So the problem number, so we'll have some number. This number will be I plus 1. So I, whenever you range through something, I starts from 0. So that's why you want to have I plus 1, because 0 plus 1, and then it's going to be 0, 1, 2, 3, 4. But we want to print out as 1, 2, 3, 4, 5. That's why there's a plus 1 everywhere. And you want to print out p.q. Now, p, is the problem. Problem means this whole thing, which has a question and an answer, right? So you know that problem has a question and an answer. So when you say problem.q, so p has all the problems. P has all the problems. When you say problem.q, basically means that the question in that problem is what you can access very easily. Question in that problem. So you're printing out every single question, and then you will obviously wait for the answer and blah, blah, blah. You will process the answer. Okay. Now we will call our go routine. So we are using channels and we're using go routines. And you will now scan. So when you use scanf, you're basically saying that you want to scan whatever the user is going to input into the CLI. And this will be stored in this answer string that you have created here. We'll use our answer C channel, answers channel, and we will write that answer there. So when you make an arrow like this, you're basically writing the answer there. Close. So when you put this, basically means that the routine will call itself. And then you want to use the select. So in select, what happens here is that you will, you can wait for multiple operations. So I've told you that there are two things that can happen. One is that you reach the end of all the questions that you were supposed to ask. That's one eventuality. Second eventuality is that your timer runs out. So you've set it for 30 seconds, but it might run out. It'll run out at 30 seconds, and you don't want the program to continue after that. You just want to give the user 30 seconds to answer that. So this is the second thing you can do. So you'll say fmt.println and break problem loop. Case answer. And now we want to check out the other eventuality. So this is the eventuality that we've handled here, is that the timer has run out. So you want to break from the problem loop. Problem loop was this. Now that makes it easy for us to break from that. Now the second eventuality is you want to handle if the error, the number of questions have gone out. So first, before that, you want to check for the answer. So we'll say if I answer. So what you'll do is you'll take whatever value is there in answer C, and you will take that into I answer, because you want to be able to process that. So if I answer is equal to p.a. Now P is the problem, you know that, because a problem has Q and A, question and answer. So P had a question, we handled that earlier, p.q. Now this is p.a. So we're checking with the right answers. The answer that the user has given is in our channel answer C, which we are taking in I answer right now. And we're checking that with the correct answer, which was there in our CSV file. If they're equal, we will say correct answer is plus plus. That means we will increase or increment the value of correct answer. And then you want to say the other thing that I told you about is if you've run out of questions. So that's also one place where you want to end this program. So whatever length you have in the entire problem is -1. If I has become equal to that, then you want to close this channel. Perfect. And you want to now calculate the result and print out the result. So calculation has already been done because this was correct answer plus plus. That's all you want to print out. So you'll say fmt.printf. You'll say your result is this much out of this much out of %d/n. Okay. So correct answer is your result, obviously, because that's what we incremented. And the length of the problems is the total number of questions you have. So the answer you'll get is your result is 3 out of 5 or 4 out of 5 or 5 out of 5, depending on how many answers you got correct. Okay. And that's all that magic is happening out here, because we're checking the answer that the user is giving in this answer C channel. This is why we created the channel, right? So you scan from the user, you pass that into answer, which is a string, and you push that answer into the answer C channel, and then you pick it up from there into I answer variable, and then you check that with the CSV file, the actual answer there, if it's correct or not. If it is correct, then you increment that correct answer variable that you had created earlier for this purpose, and you will then say printf press enter to exit. Okay, and that enter value you will say answer C. Awesome. So at a first glance, everything looks all right to me, because we followed so much of planning, we followed so much of commenting, that I think there shouldn't be an error right now, but we'll try running the program and let's see if there's an error. And also I'm using these extensions that should ideally catch the errors for me. So let's hope for the best. Let's see if there's any error or not. We'll try running the program now. We'll say go run main.go. So it's this seems to be working fine. I'll say 92. I'll say 130. Say 163. And here the answer should be 135, but I'll say 23. Here the answer 87. So it should be, answer should be 4 or 5. Yeah, perfect. It's working. It says 4 out of 5. Press enter to exit. And let's see if the timer thing is also working. So I'll run it again, and I'll just write something. I'll just wait for 30 seconds. Let's see if things work as expected, because these are the two test cases. Both of these test cases should ideally run properly, and that's when we can say that the program is working properly. And whatever these test cases you try and check in manually, you can also later on convert them into test cases. So I'll cover that in one of the future videos on how to write test cases in Golang. But essentially what you're doing is you're just checking these things like manually. Whatever you're checking manually, just want to convert that into a test case, and those test cases will run before you want to put your code into production. So see, it's working perfectly. It says your result 0 out of 5 because timer has run out. Press enter to exit. Everything works perfectly. This was the program. Do subscribe if you haven't subscribed already. Share this project, share this video with your friends, because obviously this is awesome content, right? You don't get the content like this on YouTube. Golang projects is very difficult to come across. And I have a course on Golang on Udemy. If you haven't bought it, please enroll into it. There are 3 awesome projects just like this. I've explained them really well. You should check it out. Buy that course. Not very expensive. You'll learn quite a bit. And I'm working on a masterclass course as well for Golang and for Rust. So I hope to see you there. Thanks a lot for watching, and I'll see you in the next video.